Kia ora Year 12. This video is going to do one of the vector problems from the May June 2015 Pure paper. So this is the first question. We're given the straight line that goes through the following 2 points. So this point and this one, and the vector equation of a second line, which is this one here. So we have to show that lines L1 and L2 are skew. Then we have to find the acute angle between the second line and the direction of the x-axis. So to show that two things are skew, we've got two steps. First, we have to show that they're not parallel. And then we have to show that they don't intersect. So let's get on with writing that first line in the form with the vector equation for the line. So L1 is going to have a position vector, 0, 1, 5, plus a direction vector. And we'll put a scalar of t with that one. So it's going to be 2 minus 0, negative 2 minus 1, and 1 minus 5. And we can rewrite that now and clean up the direction vector. So it's going to be 2, negative 3, and negative 4. So what I need to do is to compare that direction vector with this direction vector and show that one's not a scalar multiple of the other. Right, so are the direction vectors scalar multiples? So what we need to solve is 1, 2, 5 is equal to k times 2, negative 3, negative 4. Now it's really obvious that they're not, but let's do it properly anyway. Working with the first equation, we get 2k equals 1, k is equal to 1/2, but 2 is not equal to negative 3 times a half. So that's from equation 2. So let's do some nice labelling. So we've got no solution. So we can say the lines are not parallel. So that's the first bit. Now we want to show that there's no point on both lines. So if they intersect, what can I say? So this is part 2. If they intersect, then 2t is equal to 7 plus mu. 1 minus 3t is equal to 1 plus 2 mu. And the last one gives me the third equation. I can pick, oops, I haven't lined that up very well. I can pick any two of those, solve them simultaneously, and then sub the values back in. So if we work with these two, I'm actually not going to do all of this because I think all of you are confident with the skill. So we've got 1 minus 3t is equal to 1 plus 2 mu. So make sure that you go through and you solve. You should get down to t equals 2, and then we take that and we substitute it back in, and we get t equals 2 and mu equals 3. So they are my proposed values that will give me a point of intersection. But now we're going to substitute them into this one here, and we're going to show that that doesn't work. So we're going to write something like this, but 5 minus 4 times 2, making our substitution really clear. So 5 minus 8 gives me negative 3, which is not equal to 5 times 3. Therefore, there's no solution. I'm going to go on to the next slide so we can write this out nicely. Right, so there's no solution for mu and t. So we can say the lines don't intersect. And that means that because they're not parallel and they don't intersect, the lines are skew. So that's good. That's the first part of the problem done. Now, what was the last bit? I've got to try and remember. We had to show the acute angle between the x-axis and line L2. Right, so L2 has got direction vector 1, 2, and 5. The x-axis has got direction vector 1, 0, 0. So the thing we need to remember here is that cos theta, the angle between the two lines, is defined as the dot product divided by the product of the magnitudes. So in this case, we get this. Cos theta is equal to 1 times 1 plus 2 times 0 plus 5 times 0 divided by the magnitude, so 1 squared plus 2 squared plus 5 squared times the square root of 1 squared plus 0 plus 0. And that gives me 1 over the square root of 30. So my very last step here is to say that theta is equal to cos inverse of 1 over root 30, and that gives me 1.39 radians, or if I really don't like radians, it's equal to 79.5 degrees. Okay, so that's that question done. That's long enough for now. I'll do a couple more over the next few days. Thanks for watching.